All right, ladies and gentlemen, we are continuing with the same topic as yesterday. I don't feel like we got enough into it, so we're still dealing with chapter 7-6. We're going to do the same goal as yesterday, having to do with exponential growth and decay. Okay, so you don't need to write a new goal today. What I want to do is go over 3 sample problems that you might see in your practice today. You're going to do 10 marks for practice. So there's just 3 quick sample problems I want to go over with you. The first one states the population of a bacteria colony doubles every hour. Which equation represents the number of bacteria cells, y, after x hours, assuming that the colony started with a single bacteria cell? So remember, we're dealing with y equals a1 plus the rate to the power of t time. So which of these examples would correctly represent this situation? Well, remember, A is our initial amount, and it says our initial amount here is a single bacteria cell. So that means it's not the last one. Okay, now it says it doubles every hour. That means it increases by 100%. So that's 1 plus 1, or 100%, which would give us a 2, which makes sense because it's doubling. So our answer here is letter C, 1 times 2 to the x power. So when you see something that does not have rate, instead of using this formula here, you can actually just revert to that basic geometric. And B could be doubles, which is times 2. It could be triples, which is times 3. Quadruples, times 4. It could also be decay. It could say it halves, which is times 1/2. So these are just things to keep in mind when you see problems that don't deal specifically with percent. Okay? Take a look at this one. This is one of those problems that I told you to ignore in that first round of 10 marks that we did. You're going to see them again. So now this formula should make a little bit more sense. P is what we call the principal amount. The initial amount. Same idea. R is still your rate. T is still time. And now the thing that's been added here is N. And N is the number of times it's calculated. It's calculated. So what happens sometimes is when we have a bank account, they say it's calculated monthly, compounded monthly. It's calculated daily. Now, the more often they calculate it, the better outcome you're going to have. So let's fill in this information here. It says Bradley deposits $25,000 into an account that pays 12% annually. That's each year. So the initial amount of money in the account is $25,000. The growth rate, if the interest is compounded monthly, is the rate 0.12 divided by 12, because it's compounded monthly, 12 times in a year. Okay? The amount in the account to the nearest dollar at the end of 2 years, if the interest rate is compounded monthly, is. So now we actually have to fill in the full equation here. So that's going to be 25,000, 1 plus 0.12 divided by 12, raised to the 12 times 2 power. Now I would make sure that you can enter this in your calculator and get the correct answer. Okay, because it's a little bit complicated typing all that mess in. You're going to want to use parentheses here, so you're going to have 2 sets of parentheses. And that's going to give you $31,743.37 rounded to the nearest hundredth place, because that would make sense for dollars. Now, does that amount make sense to us? Well, if we start with $25,000 and you have a 12% interest rate, after 2 years, you should have more money. And $31,000 seems about right. Imagine that, you guys. If you actually opened up a savings account, how much money you can save. Okay, the last one here I want to think about is, it says, which function represents exponential decay? And for you to remember, we need to keep an eye on the b. When b is greater than 1, it's going to be growth. And when b is between 0 and 1, it's going to be decay. So what have we got here? Growth or decay? Well, remember, we're looking at the b, and that's bigger than 1, so that would be growth. How about this one? Looking at the b, that's bigger than 1, that's growth. How about this one? Oh, that's less than 1. That's decay. And this one, greater than 1, growth. All right, so keep an eye on those. Those are some of the problems you're going to see on your practice tonight. You're doing 2 10 marks activities. The first one I'd like you to start with is understanding exponential growth and decay. The second one is more review. It's operations with scientific notation. Now, we will still do one more activity on Thursday, something new, and then Friday we'll start reviewing.